7. Basics of geometry. Points to learn. Basics of geometry. Types of lines. Point of intersection. Measuring the line segments. Parallel lines. Shapes. Plane surface and curved surface. Closed and open figures. Congruent figures. Review exercise. We have learned about straight lines and curved lines in the previous classes. Straight line, curved line. Different kind of lines are horizontal, vertical and slanting. Horizontal line, vertical line, slanting line. Shapes can be triangles, squares, circles, rectangles, etc. Circle, rectangle, triangle, square. Basics of geometry. Point. A dot represents a point and is denoted by any capital letter A, Q, B, P, R, S as shown in the below figure. A point shows a definite position or location. A, Q, B, P, R, S. Line segment. When we join two points using a straight edge or a ruler, a line segment is obtained. AB is the line segment written as AB. Points A and B are called endpoints. Properties of a line segment. It has two endpoints. It has a defined fixed length. The length of a line segment can be measured with the help of a ruler. A line segment is a part of a line. Ray. When we extend a line segment, say xy, in one direction only, we get a ray xy, as it is written as xy. To show extension, we put an arrowhead at y, as shown below. X, y. Properties of a ray. It has only one endpoint. It has no definite fixed length and it cannot be measured. Since a ray can be extended endlessly in one direction, we cannot draw a ray on a paper but arrow instead. Line. When we extend a line segment, say xy, endlessly in both the directions, we get a line xy and it is written as xy. To show extension, we put arrowheads on both the sides as shown below. X, Y. Properties of a line. It has no end point. It has no definite fixed length and cannot be measured. Since a line cannot be extended endlessly, we cannot draw a line on a paper but instead put arrow on both the sides. Types of lines. Curved line. Look at the 2 points given below, A, B. Join these points with a free hand and not by a ruler. On joining these points by hand and not by a ruler, we do not get a straight line but a curved line. Thus, AB is a curved line. Horizontal line, sleeping line. Look at the way you keep your pencil on your desk. You place your pencil on the desk horizontally. Also, see the way you sleep. We lie down horizontally on our bed to sleep. Thus, a line drawn in a sleeping way is called a horizontal line. The line AB drawn below is called a horizontal line. vertical line, standing line. Look carefully at the electric pole on the roadside or the lamppost on the park. Both the electric pole and the lamppost stand vertically on the ground. Have you ever noticed the way we stand? We stand vertically. Thus, a line drawn in a standing way is called a vertical line. A line PQ drawn alongside is called a vertical line. Oblique line, slanting line. In the illustration on your right, a ladder is put against a wall. The ladder is lying in a slanting position against the wall. Similarly, a line drawn in a slanting position is called a slant line or an oblique line. Also, we can say that a straight line which is neither horizontal nor vertical is a slant or an oblique line. A line EF drawn alongside is called an oblique line. EF. Point of intersection. When two line segments cross each other, they meet at a point. The point at which two or more than two line segments meet is known as the point of intersection of these line segments. A. In the given figure, the point of intersection of the line segments PQ and RS is 0. PQ, RS, 0. B. In the given figure, the point of intersection of the line segments AB and CD is B. AB, CD, B. C. In the given figure, the point of intersection of the line segments XY and YZ is Y. XY, YZ, Y. 1. Label all the points drawn in the figure given below. 1 has been done for you. 2. From the figure given alongside, identify and name. A. The horizontal lines. B. The vertical lines. C. The oblique lines. D. The points of intersection of lines AC and BD. E. The point of intersection of lines AB and BC. 3. Identify and name the following lines. Measuring the line segment. We all know that a line segment has a definite length and it can be measured with the help of a ruler or a scale. Let us study the given scale carefully. Suppose we have to measure the length of the line segment XY shown alongside. We place the ruler along XY in such a way that one of its edges XY and the mark 0 of the ruler is at X. Now read the mark of the ruler pointing at the point Y. The reading of the scale at Y gives the length of the line segment XY in centimeter. Look carefully. It reads 3 centimeter. So, the length of XY is equal to 3 centimeter. Point X is the place from where we start the measurement and point Y is where the line ends. That is, its length is 3 centimeter. To draw or construct a line segment of a given length. Suppose we have to draw a line segment of length 5 centimeter. Here are the steps to be followed. 1. Place the ruler on a paper and hold it firmly. 2. Take a sharp pencil, mark point A against the zero mark of the ruler on the paper and a point B against the 5 centimeter mark of the ruler. 3. Join the points A and B along the edge of the ruler with the pencil. Thus, we get the line segment AB is equal to 5 centimeter. Parallel lines. Lines which are at an equal distance from each other and never meet are called parallel lines. The symbol for parallel lines is. Let us have some fun and learn along with it. Take your scale, place it on a paper and hold it firmly with one of your hands. Holding the scale on a page, draw two lines, moving your pencil lightly along both the upper and lower edge. AB, CD. This is what you get. AB is parallel to CD. Now notice these two lines carefully. You will observe that they are at an equal distance from each other and they will never meet even if you make them longer and longer. You can get a variety of examples of parallel lines from your surroundings, such as the distance between the edges of a window frame, pencil box, wall, etc. 1. Measure the following line segments. 2. Draw line segments of the following measures. 3. Identify the parallel lines in these figures and write their names. Shapes. We have learned about plane figures, shapes, and solids. To recapitulate, let us see some of the solids. Now, let us go through the properties of each of these solids. Sphere, cylinder, cuboid, cube, cone. Cuboid. We see so many objects around us which have a shape similar to that of a cuboid, such as a matchbox, wooden almirah, brick, book, etc. Here are the properties of a cuboid. It has 6 plane surfaces, 8 vertices, 12 edges. Each face of a cuboid is rectangular in shape. The opposite faces of a cuboid are identical. Cube. Objects such as ice cubes, sugar cubes, dice, chalk box, etc. resemble the shape of a cube. Here are the properties of a cube. A cube has 6 faces, 8 vertices, 12 edges. Each face of a cube is square-shaped. All faces of a cube are identical to each other. Cylinder. Objects such as a gas cylinder, a can of soft drink, tin of talcum powder, measuring jar, drum, tube light, water storage tank, thread reel, log of wood, etc. are in the shape of a cylinder. Here are the properties of the cylinder. A cylinder has two plane surfaces and one curved surface. It has two edges in circular shape. It has no vertex. The base and the top of the cylinder are of the same shape and size. Sphere. Objects such as a woolen roll, football, globe have the shape of a sphere. Here are the properties of a sphere. It has only one curved face. It has no vertex and no edge. Cone. Objects which resemble a cone shape are an ice cream cone, funnel, conical tent, clown's cap, birthday cap, etc. Here are the properties of a cone. It has one plane surface, which is the base of the cone. It has one curved surface. It has one vertex. It has one circular edge where the curved face meets the plane face. Let us summarize. Solid shapes, vertex, edge, plane surface, curved surface, cuboid, 8, 12, 6, 0, cube, 8, 12, 6, 0, cylinder, 0, 2, 2, 1, sphere, 0, 0, 0, 1, cone, 1, 1, 1, 1. This table will help you revise the properties of each of these solid shapes. 1. Identify the shape of the following objects. 2. I am a solid shape. What am I? 3. Fill in the blanks. Plane, surface and curved surface. We will now study about the plane surfaces. The common plane surfaces are circle, rectangle, triangle, square. There are some objects which have either a plane surface or a curved surface or both. Let us understand by some examples. Objects with straight edges have a plane surface. Chalk box, tabletop, blackboard, cupboard. Objects with curved edges have curved surfaces. Orange, ball, globe. Objects having plane and curved surfaces. Drum, paint roller, wood. Square. The plane surface of a cube is called a square. Here are the properties of a square. A square has four sides. All four sides of a square are of equal length. A square has four vertices. Remember, the point where two or three sides meet is called a vertex. It is denoted by a capital letter. Rectangle. The plane surface of a cuboid is called a rectangle. Here are the properties of a rectangle. A rectangle has four sides. The opposite sides of a rectangle are equal to each other in length. A rectangle has four vertices: P, Q, R, S. side, vertex, triangle. The plane surface of a cone is called a triangle. Here are the properties of a triangle. A triangle has three sides, three angles, and three vertices. So, triangle is a figure formed by three line segments A, B, C, side, vertex, circle. The plane surface of a cylinder is called a circle. Here are the properties of a circle. A circle has a curved surface. The distance from the center of the circle to any point of the circle is always equal. A circle has no edge and no vertex. Circle. 1. Write yes or no. A. Does a circle have a curved surface? B. Is the meeting point of two adjacent sides of a plane figure called vertex? 2. Fill in the blanks. Closed and open figures. Closed figures. All the figures that you have studied so far, such as rectangles, squares, circles, and triangles, are examples of closed figures. A closed figure encloses a region within its boundary, and this region is called the interior of the closed figure. If you start from any point on a closed figure, trace its outline, you will come back to the starting point. The figures shown above are all closed figures. Open figures. Open figures are just the opposite of closed figures, and they do not enclose any region within their boundary lines. If you start from any point on an open figure, trace its outline, you do not come back to a straight point. The figures shown above are all open figures. Congruent figures. Two or more figures are said to be congruent figures if they are exactly the same in shape and size, such that if you place them one above the other, they completely overshadow each other. Look at these triangles. Figures 4, figures 3, figures 2, figures 1. Figure 1 and figure 2 are exactly the same in shape and size, and thus they are called congruent figures, while figure 3 and figure 4 do not match with figure 1 and figure 2. Draw the following: A. Any one closed figure. B. Any one open figure. C. Any one closed figure with straight line segments.